Hello and welcome to the 19th Annual Caithness International Science Festival and our first live virtual festival event entitled Stargazing Under the Dark Skies of Northern Scotland. I'm Ian Bakey, I'm the Chair of Science 03, and with me tonight is Nicola MacLeod, the Festival Coordinator. Hi Nicola. Joining us from Caithness Astronomy Group are Gordon Mackey. Hi Gordon, who will deliver the feature presentation, and Neil McLean and Christian Willem, who, weather permitting, will carry out the live observations. And we've got John Hilton and Ian Darby, who will be moderating and assisting with the question and answer session. Before we begin, thanks. Before we begin, a little bit of housekeeping. The event is being recorded, however, your screens are not. This has been a popular event, so please direct all questions through the Q&A, that's the button at the bottom, and we will answer as many as we can. As an audience, you have the opportunity to upvote questions. So if there was a question someone else had added that you wanted to hear answered, give it a thumbs up and it moves up the list. I'm now going to hand over to our feature presenter tonight, Gordon Mackey of Caithness Astronomy Group, and we hope that you enjoy the presentation. Thank you.
Okay, thank you very much for that, Ian, and thank you to Caithness International Science Festival for inviting Caithness Astronomy Group to contribute again this year. I think, if you bear with me a second, while I organise to share my screen, and if I can just confirm that you are now seeing, yep, that's fine, you're now seeing the presentation. Excellent. It's always a bit worrying with these things that what I'm seeing in my screen is not necessarily what everybody else is. So, just to say again, thank you very much for allowing us to contribute to the Science Festival again this year. Obviously, it's a little bit different to the normal arrangements, but what we thought we could do virtually is to explain why there are so many people in the Caithness area and the north of Scotland that are keen amateur astronomers, keen stargazers. And the bottom line is because it's a fantastic place to do stargazing, other than when it's cloudy, of course, which I'll mention again in a moment regarding our arrangements for live viewing tonight. So I thought it'd be worthwhile for us to give a fairly basic presentation highlighting some of the things that you can see in the night sky from the north of Scotland, and hopefully what that will do is encourage perhaps a few more of you to wrap up and venture out and gaze skywards from a suitable location. So let me, yep. The Science Festival this year, Ian is going to give a bit more detail on the events that are coming up, but I think it's worthwhile for me to say that Caithness Astronomy Group will be planning another number of events later in the month where we'll be concentrating on the moon. So I'm going to keep my fingers crossed, and if everybody else can, keep their fingers crossed for clearer skies at that point. Hopefully we'll be able to live stream telescope views of the moon. But there are lots of other space-related events, I'm delighted to say, during the month of March. And I, for one, will be tuning in probably to what looks like about 3 or 4 events every week. So I'm not sure where I'm going to find time for stargazing amongst that, but it will be well worth joining those events as well, I'm sure. So this evening, this evening the plan is that I'll give a presentation to go through what you can see in the night sky from the north of Scotland and why it is so good for stargazing. The plan was to also have a short live stream using dedicated astronomy cameras to show you what's in the sky at this time of year. Unfortunately, that is looking unlikely at the moment because of the situation with the cloud cover. But we've got Neil McLean and Christian Wilhelm are both standing by with the cameras ready if we do get a gap in the clouds. And as Ian's already said, it really is a big team effort at the moment. And Ian Darby and John Hilton are in the background, keeping an eye on things, keeping an eye on the Q&A, along with Nicola and others. And I'm hoping that if there's any difficult questions, they'll be busy on Google as well, so that there's answers prepared when it comes time to do that at the tail end of the event. So there's a couple of, or there's 4 key things that I'm going to try and cover tonight. First of all, why the north of Scotland is good for stargazing. I'll then move on to give an idea of some good locations to do stargazing, or if you're interested in night sky photography, where some really good spots are for doing that. Then probably the majority of the talk is on what can be seen by stargazers and when. That's always a difficult thing. Not everything can be seen on every single night of the year. So you do have to have an appreciation of which times of year and under which conditions you can see certain things. And then I'm going to wrap up with a brief tour of what's in the evening sky at this time of year. So if anybody is wanting to do a bit of stargazing over the next month or two, then that 10-minute or so slot at the end will give them an idea of what they can see in the sky. For some reason, my slide is not advancing. So bear with me for a second while we try and resolve what's going on. It's funny how everything manages to work fine when you do the trial run before you connect to Zoom, and then as soon as you connect online, you have a problem that things freeze. Okay. So almost all of the images that I'm going to show tonight are ones that I've taken. The main reason for that being it was quite easy for me to pull together the presentation that way. But I have to say I have enlisted a few friends to share some of their photographs and time lapses. Main reason being they are quite spectacular. So there are many other people out there that are producing fantastic night sky images, especially at this end of the country. Not all of them are astronomers, some of them are just keen photographers, and I will mention a little bit about what you can do photography wise if you're keen in that towards the end of the talk. But by far the majority are going to be ones that I've taken. I would like to thank though Karen Monroe, Stuart Watt and Maciek Winiarczyk for allowing me to share some of their images tonight. Okay, so why is the north of Scotland good for stargazing? Well, one of the things that I like most about it is that there are some absolutely fabulous scenic spots that you can go to and just enjoy the surroundings while gazing upwards. The other advantage is during the winter months, there are plenty of hours of darkness. So for busy people that have to be up early in the morning for work. The winter time has the added benefits in the north of Scotland that you can finish work, you can sort out your dinner, and still have time during the hours of darkness to spend maybe 2, 3, 4 hours out stargazing and get to bed at a sensible hour. That's not necessarily the case further south. You don't get as many hours of darkness. So certainly the north of Scotland, places like Caithness and Sutherland are well suited to stargazing in that respect. The other thing is, at this end of the country, there are many places where you can go for unobstructed views of the sky. So you get the fully immersive effect, 180-degree views in all directions. And what you can see here is a panorama that was taken by Maciej Winiarczyk at Lochmore, and I think you'll agree it's absolutely stunning. You've got the Milky Way on the left-hand side rising above the loch, and bright aurora display shining in the sky and reflected in the loch itself. So there are the advantages for the north of Scotland, whereby you can see lots of sky. There are plenty of daytime photographers that will tell you the big sky experience in Caithness and Sutherland really does help with photography and with enjoying the views. And that doesn't change at night time either. So moving on from those fantastic images that Maciej has taken there, I want to show you one of the other reasons why we're in a good situation in the north of Scotland. If you look at the arrow in the top left, is pointing towards our place in Europe. And this illustration shows where the man-made light pollution is spread across Europe. And over the last 10, 20, 30 years, unfortunately for stargazers, the light pollution has increased. And light pollution does affect the quality of the views that you get when you go stargazing. You will notice, though, in the far north of Scotland, this region here, that the sky is not affected by much in the way of light pollution at all. And that's a really big bonus for this part of the world, this part of Europe. And it's been well recognised by quite a lot of people in other countries. It's not unusual for myself and others to bump into tourists, people from other parts of Europe, other parts of the world even, who come to the north of Scotland to do a bit of stargazing and also in the hope of seeing the northern lights. So dark skies is a definite plus point. And what it does mean is, for us in the north of Scotland, we don't have to travel far to find a suitable observing location. So myself, even in the town of Thurso, so one of the biggest towns, if not the biggest one at this end of the country, even there, the sky is dark enough in my back garden that I can do some serious stargazing. And this is actually a photograph I took from my upstairs window a year or two ago, and I'm quite sure you can see how clear the aurora is and all the stars dotted about the sky. So you don't have to go far to do stargazing. Not everybody will have quite as good a view if you live in the town or in a village, but if you are a reasonable distance away from the nearest streetlights, you will get quite a good view pretty much anywhere in the north of Scotland. Now, if you think that's quite a good view to have from your house, wait till you see the next one. This is a time-lapse footage from Karen Munro, and she's lucky enough that her house looks out over Thurso Bay, so it's looking north. And what she did one evening because she had to get up early for work the following day, but she knew the aurora might be interesting overnight. Well, she set up her camera to record what was happening outside while she went off to bed. And thanks to Karen for sharing this with us. Some of you may have seen it in the BBC news website a few years ago. So this is the view from her living room, and it spans most of the night. So towards the end of the video sequence, you will see the sky starting to brighten as dawn approaches. What this video does highlight is that there is a fair chance, even if you are a keen stargazer, there is a fair chance that the exciting things will happen during the middle of the night when you're asleep. But because we do have plenty of hours of darkness in winter evenings, if you get out in the evening, it does increase your chance of seeing things like the Northern Lights and other interesting events. Now, as I said, not everybody will have the perfect location in their back garden or even in their living room to enjoy these sort of views. So if you do have to travel to find a darker spot for looking at the night sky, where can you go? The bottom line is most places in Caithness are suitable. If you get a little bit out of a town or village that has street lights, that will take you to somewhere dark. And what we have in this particular map here is a number of the favourite locations that Caithness Astronomy Group members will make use of during that dark nights when the clouds permit. We normally have our events at Castle Hill Heritage Centre, and one of the reasons for that is a dark location, is easily accessible, and the car park is nice and big and safe for getting out and wandering about in the darkness. Because it is very important if you go somewhere particularly dark, and most places in Caithness in the middle of the night when the moon's not about are very dark, and you do have to consider safety. So I would encourage you that if you do decide to go out to a dark location for doing stargazing, perhaps do a bit of daytime reconnaissance beforehand, or pick one of these locations that we've identified here, the likes of Thurso Shorefront, looking out north over Thurso Bay, Castle Hill, Dunnet Head, Dunnet Beach Car Park, Duncansby Head Car Park, Noss Head. There's many places that you can pick where you can arrive in the car, park the car, and safely step outside and gaze skywards, enjoy yourself without fear of falling in a ditch or some other way hurting yourself in the darkness. But if you are venturing somewhere a bit more off the beaten track, please make sure you do it safely, and also take into account that in the winter months some of the roads may be a bit frostier, and you may want to avoid them and go to the ones that are easily accessible. So, what can be seen by stargazers and what time of year? I'm just going to run through these fairly quickly because the main part of the talk will be showing you details of these in a fair bit of detail. And I've broken it down into three groups. The first group are things that are nearby the Earth, so high up in the atmosphere or just beyond. Then there are things like the moon, the planets, comets, other things in the solar system that you may want to look at. And then there's the things in the night sky that are much, much further away. All of the things I'm going to talk about tonight are visible to the naked eye without any specialized equipment. The detail of some of them, unfortunately, is only visible through using a telescope. So there are a few things that you will need a telescope to appreciate the full detail and the technicolor glory, if you like, of the objects. And what I'm talking about here is things like planets, distant galaxies, and the like. But by the majority of the items here are things that you can just step outside, and the beginner, with their own eyes, can look for and watch if they are visible. The noctilucent clouds are only visible in the summertime. The aurora, on the other hand, during the summertime in the north of Scotland, it doesn't really get dark enough for you to see the aurora. So they tend to be best seen out with the summer months. So from mid-August through to the beginning of May. And they're not visible the whole time. It is linked into what the sun is doing. And I'll talk a bit more about that. They're best seen in dark skies. So if there is a full moon, the moonlight tends to drown out the aurora, and therefore periods round about the full moon are not ideal for observing any aurora displays that are occurring. Shooting stars, the best chance of seeing shooting stars is during the designated meteor showers, where the number of shooting stars increases quite significantly. So they happen at certain times of the year. The best ones being mid-August, which are the Perseids, and mid-December, which are the Geminids. There's lots of spacecraft travelling round about the Earth at the moment, and it's surprising how many you can see if you go out on a dark, moonless night and look skywards. You'll probably spot a satellite passing across the sky, probably one every 5 or 10 minutes at least. And certainly Elon Musk has been in the news a lot recently because he's putting lots more satellites into orbit. Zodiacal light is something that is best seen after sunset at this time of year in the spring and before sunrise in the autumn. And when it comes time for viewing the moon, planets and comets, there are websites that will give you an idea as to the best time to look for them and where they'll be visible. And that varies from year to year. So that really is a case of have a look on websites to get an update. So let's start with the first one on the list, and that is noctilucent clouds. So noctilucent clouds are night shining clouds. That's the literal translation. And they are clouds consisting of ice particles round about 80 to 85 kilometres above the Earth. And that puts them not quite at the edge of space, but they're certainly much higher than the normal clouds that we deal with and that cause the weather conditions on the ground. As I said, they're only visible during summer months, and they're not visible all over the planet. These clouds form round about the polar regions in the summer, so June, July time in the northern hemisphere, and December, January time in the southern hemisphere, round about the poles. And they tend to be visible at certain latitudes, and the UK is just in the ideal place for that. And the north of Scotland is a good position for viewing noctilucent clouds from. But this is one thing that can be seen across the whole of the UK. And the reason that we can see them is because of the spatial arrangement, the angles between us as the observer. So if I can maybe get one of you just to confirm you can see my mouse moving about the screen. If I can get a thumbs up, excellent, John, thank you. So we're the observer here on the night part of the Earth, and as we look towards the northern horizon, what we see is there'll be dark clouds that are in the out of the sunlight. So if you look at this photograph, we can see a Thurso Beach here. There are some dark clouds near the horizon here, and these represent these ones in the diagram. The noctilucent clouds are much higher up. As I said, they're up 80, 85 kilometres in altitude. And because they're much higher up to the north of us, and during the summertime the sun does not dip very far below the horizon, the noctilucent clouds are reflecting sunlight brightly. So the noctilucent clouds are very obvious in the nighttime sky, whereas the normal weather clouds are in darkness. And what that means is in the darker skies that we get in the summertime, they're not completely dark because of how far north we are and the sun hasn't dipped far below the horizon. But the consequence of that as well is that the noctilucent clouds are shining brightly in the nighttime. And once you've seen them, it's hard to forget what they look like. The downside is during June and July, they tend only to be visible between roughly midnight and 2 o'clock in the morning. So you do have to be up pretty late in the summertime to have any chance of seeing them. They are reasonably common though. So if you had 60 days of clear nights in the summertime, I would be surprised if noctilucent clouds weren't visible for a quarter or a third of them each summer. So here's a video clip which is operating a bit slowly, so I may cut this one short. But what it does show is that over the space of a few minutes, the clouds themselves will change form and position slightly. So it is something in motion for you to watch, and the fine detail of the clouds it can be quite spectacular. Okay. Now onto the one that probably most people are keen to see, and that's because a really spectacular display of the aurora borealis or the northern lights is something that you'll never forget. I'm lucky enough that I've seen many really good displays from the north of Scotland, and each one of those sticks in my memory. I can almost remember the date and month and year of it. It really does stand out as an amazing experience when you're standing on a clear dark night and the whole sky is alive with the dancing northern lights. Now, normally, the northern lights don't appear terribly colourful to the naked eye, but the detail and the colours come out really well in photographs. So let me try and explain what's happening here, because it's one of the questions I get most often is why doesn't the aurora look like it does in the photographs that I see? And really the simple answer is the camera is not quite the same as your eye, and therefore it's not going to give the same end result. So what the camera is doing during a long exposure is it's collecting the light and then adding it all together over the period of the exposure, which could be anything from several seconds to perhaps 30 seconds or more in length. So the camera's got the capability of collecting the light over a longer period of time, and the fainter aurora then can be made to appear a lot more obvious on the resultant photograph. Whereas your eye is collecting the light over fractions of a second, and as a result, it's not quite as efficient as a light collector. And what that means is it tends to look a little bit dimmer most of the time than it does in the photographs. The advantage of watching it by eye, however, is that you'll see the movement, whereas still images don't convey the movement that is clearly visible to the naked eye. And when you have the lights dancing across the horizon, it really is quite a sight to behold. The other thing to do with the colours is probably worth mentioning as well. So there's a little bit of science here for those of you that are interested to delve a bit deeper. You can do a bit of research online, but the human eye sees different colours with different degrees of efficiency. It tends to pick up green much more effectively than red in dim light. So what that means is the typical colours in aurora are green mostly, but there can also be some red. But unless the aurora is really bright, you're probably not going to see the red terribly obvious as a red colour. It may just look like a ghostly light. And part of the reason for that is also down to that the retina of your eye doesn't see colour too well in dim light, because you've got two types of cell at the back of the eye. You have rod cells and cone cells, and the cells that work best in dim light don't see colour very well. You can test that out the next time you go outside and you look at a car parked at the far end of the street, and even though you know what the colour is, you might actually struggle to make it out on a dimly lit street, simply because your eye can't see colours as well at night, unless the light itself is particularly bright. So that's an explanation for why the photographs look a bit different to what you see to the naked eye. But don't let that put you off. If you get a nice bright display of aurora that is moving across the sky, you will get a tremendous view that's well worth venturing out in the cold for. And I've got here a few photographs to hopefully illustrate that. These are fairly recent ones that were taken at the back end of 2020. So this is at Thurso Beach, and that's roughly how it looked to the naked eye. So it was a fairly bright display there. And then one from Dunnet Beach, again, not that different to how it looked to the eye. The colours were a bit more muted to my eye on that night, but you could definitely see the green there, and there was a hint of red above it. So if you want to see the Northern Lights, the next obvious question is when will they be visible? Unfortunately, it's not a case of somebody flicks a switch at 7 o'clock each evening in the winter. Everybody can pop outside, and just like the Christmas decorations, you can enjoy the view. They are a natural phenomenon, and as a result, they can be a little bit unpredictable. But because we now understand quite well what causes them, there is a degree of predictions that can be made to when the aurora will be visible. And the bad news is, for me to go into the whole detail would be at least another hour's worth of quite technical stuff. So I'm going to do my best here to try and explain in probably no more than a couple of minutes, and leave you to do a bit of research yourself if you're keen. This presentation will be available online afterwards. There is a Caithness Science Festival YouTube channel being set up, so you'll be able to have a look at some of the links that I've put at the bottom of some of the slides, and you'll be able to gather more details from it. But essentially, the aurora is due to the solar wind. So it's weather conditions that our sun generates, and one of them is a wind that comes from the sun and travels through space. So you can see the sun represented on the left-hand side here. The solar wind is all the charged particles that it throws off at high speed. They travel through space, and if they come in the direction of the Earth, they can distort our magnetic field. And if the solar wind is strong enough and of the right magnetic polarity, it can essentially distort the magnetic field enough that leads to the atoms in the upper atmosphere gaining extra energy, which they give off as light. So the oxygen atoms in the upper atmosphere will give off green light, and there's other ways that oxygen can give off red light. So that's the two typical colours of the aurora. There are also sometimes bits of purple or pink in the aurora as well, and that's associated with nitrogen atoms or nitrogen molecules in the atmosphere being affected by the solar wind. So there's the quick summary. That doesn't really tell you exactly when the aurora is going to be visible, but because we understand how the aurora is generated now to a large extent, if we monitor the solar wind conditions, it can give us an idea as to whether it's going to be suitable for generating the northern lights and for a display to be visible from the north of Scotland. Now, there's a lot of technical things in relation to the solar wind, a lot of parameters that can affect whether the aurora will happen or not. And that's I suppose, the fun in the chase if you're trying to spot the aurora. The good thing is, for those that don't want to go into the technical details, there are websites that will give predictions, and they do it in ways that can provide details to those that understand the technical stuff, but they also color code things. And essentially, the three main parameters in the solar wind, they'll give indicators for those, and the color coding basically is that the more it's towards the red end of the dials and away from the green end, the more chance there is of aurora. So bottom line is they try to make it reasonably simple for understanding, and they provide forecasts for whether the aurora is likely to be visible or not. So there is a lot to take in there. What I would say is that on Caithness Astronomy Group, we have a one-page summary of some of the key points. So there is a link there at the bottom that if you go onto the website, the Caithness Astronomy Group website, you can go on and access that basic information. But if you want finer details and up-to-date forecasts, the websites like Space Weather Live are ideal for that. You also get phone apps that will enable you to get notifications when you're out and about, and there are Facebook groups where people will share whether the aurora is visible or not. For those that want to look a bit further ahead as to the chances of aurora, here is the forecast for March. Now, the good news is you'll see there's plenty of yellow and red bars there. That means that there could well be some aurora activity in the month ahead that will be visible from the north of Scotland. It's always best, though, this is the long-term forecast, you need to check nearer the time because there are more detailed forecasts for the day ahead. So let me just play this video clip, hopefully. And it's playing extremely slowly again, so my apologies. For some reason, we don't seem to be doing too well with videos tonight. But what you're seeing here is an absolutely fantastic time lapse put together by Maciej Winiarczyk from, you'll no doubt recognise the Duncansby Stacks. And what you'll see, if I maybe take it back and see whether it'll play from there, from a bit further on, you may see some lights moving along the cliffs here. The heading at the top of this slide is most important. You have to get the timing right to see the aurora. It doesn't happen all night long, not very often anyway. It tends only to happen in bursts of activity, sometimes only for a minute, sometimes for half an hour. But if you don't get the timing right, then you won't see anything quite as spectacular as Maciej managed to capture here. Now, I'm going to have to apologise again because the video is really not showing it to its best. But I remember this night really well because Maciej was well prepared. He got to the cliff tops well in advance, managed to capture, if I can manage to get the right part of the scene, managed to capture the really good part of the display, and myself and several others appeared just as the clouds rolled in and the aurora kind of died down a bit. So timing really is everything. But when you do time things right, you can get views that are absolutely incredible, that you'll probably never forget. So here's an example from Dunnet Head a few years ago, one from Strathy. Now this one I never noticed on the night, but it's in the shape of a little green man or alien. I have to admit, if I'd looked up in the night sky and saw that looking back at me, it may have given me a bit of a fright. But you time it just right with going out to view it or taking your photographs, you can get some spectacular results. And if you do get a good display, the important thing is, as with everything else these days, make sure you take a selfie to record the moment. And if you're really lucky and and good at photography, you can manage to take perhaps one of the most outrageous selfies I've ever seen in my life. Stuart Walk took this one. I think it was from Scrapster Hill of Aurora back in 2014, and I I was watching the Aurora that night, and it really was amazing. I just wish that I had the foresight to try and get a photograph like this. It certainly looks like Stuart is conducting the Aurora display from the hilltop. It's really quite a spectacular image. Another thing that you need to get your timing right for watching the event or for taking photographs is for meteor displays. You'll see here in the top right hand corner there is a shooting star or meteor generated from dust entering the Earth's atmosphere, burning up, and as it does so, it glows white hot, and you see it as a streak of light across the sky. Now, I must have taken tens of thousands of photographs of the night sky, and I can probably count the number of good meteor photographs that I have on a single hand. I seem to be particularly unlucky when it comes to trying to capture them, so much so that um, whenever myself and others go out photographing and we try to capture meteors during a meteor shower, I'm convinced that others look at where my camera is pointing and they point their camera in a different direction because that increases the chance of them managing to capture a meteor on the frame. So, other thing that you can see in the night sky, as I mentioned, is spacecraft, such as the International Space Station. The timing of visibility of these can be seen on various websites, but the website heavensabove.com is an excellent one to check for when you can see the spacecraft and in particular the space station. What does the space station look like as it travels across the sky? It just looks like a bright star. And from Caithness, it takes maybe 2 to 3 minutes to traverse from the southwestern horizon across the south to the southeastern horizon. But it's not visible every night. If you want to see it, like I said, check out that website. One thing that is blatantly obvious, and you don't need dark skies to view, is the moon. The dark skies may not be an advantage, but the long winter nights can definitely help because it gives you plenty of time to get detailed images of the moon. And hopefully, in 2 weeks' time, it will allow us plenty of opportunity to live stream some views of the moon from Caithness during one of our upcoming events. Planets are other things that tend not to need dark skies because they are particularly bright, most of them anyway. And here we've got the planet Jupiter on the top left and the planet Venus on the bottom right. And to the naked eye, they just look like bright stars. However, if you look through a small telescope, and these are images captured through small telescopes, you can start to see detail. So a small telescope will allow you to see things like the cloud bands on Jupiter. A large pair of binoculars, believe it or not, will allow you to see Jupiter and 4 of its brightest moons. So you don't even need a telescope to see Jupiter and 4 of its moons. Venus can be seen to show different phases, just like the moon does, and that's because it orbits closer to the sun than the Earth does. Saturn, you can see it's a lovely ring system, and on Mars, you can see some of the surface markings. For those of you that have been following the recent mission by the Mars rover Perseverance, it has landed at the Jezero crater, which is about there on the planet Mars. Dark skies are definitely needed, however, to see the Milky Way and to see this other phenomenon here, the zodiacal light. So I'm sure a lot of people that have done stargazing on a clear moonless night will have noticed the milky band of light stretching across the night sky. And here you can see it from Skrza Harbour, so that's the bright lights of Wick in the distance there. Here you can see the Milky Way stretching across the sky above the zodiacal light. Now, these are the sort of things that probably the majority of the population in the UK cannot see from their gardens. But I can see the Milky Way from my back garden in Thurso very faintly. You don't get such a good view unless you go to a darker location in the county. And the arrow here is pointing to a couple of smudges. This is actually the Andromeda Galaxy, which is a galaxy 2.5 million light years away. So it's our neighbouring galaxy, but it's a mind-boggling distance away from us. So why does the Milky Way look like it does in the night sky? Why do we see a band of light? And the reason for that is because of our position within the Milky Way and the shape of the Milky Way. The Milky Way is a spiral galaxy. So looking from above, you can see this spiral shape quite clear in the top diagram. Looking edge on, the Milky Way looks like 2 fried eggs stuck back to back. And our sun is not near the central bulge, but it's out on one of the spiral arms. And what that means is when we look in the night sky in a certain direction, we'll be looking along the plane of the Milky Way where there's a higher number of stars in the sky. And that's what causes the Milky Band that you see. All of the stars you see in the night sky are part of the Milky Way, but the majority of them lie in this plane along the spiral arms that expand out from the central bulge of our galaxy. Here's a photograph. It shows the Milky Way arching across the sky. You can see the zodiacal light, that ghostly light coming up from the horizon, planet Venus there, and you'll recognise the aurora on the horizon. When you're out stargazing, it's always worthwhile keeping a close eye out for unusual sightings. And one of the things that was actually spotted this week from the north of Scotland was a phenomenon known as Steve. Now, there's a really interesting story to do with this, but I'm not going to tell it tonight. It would take too long. But Steve has been the subject of some citizen science where amateurs have been providing details, data, and observations of a strange light in the night sky that seems to be associated with the aurora. It's not the same as the aurora, but it is associated with the aurora displays. And you can see here, it was talked about at the British Astronomical Association, a recent lecture there. And the images that they're showing are views of Steve taken during a Caithness Astronomy Group observing event. So we managed to see some quite spectacular views of it. And what the professional scientists then, who had access to orbiting satellites, is they teamed up with citizen scientists, primarily across North America, to tie in the satellite data with the observations on the ground to try and understand better what is causing this strange light in the night sky. So for those of you that might want to understand more about it, there is a web link there that you can have a look at. So, as well as in the night sky, when you're out and about stargazing, you might notice some unusual things as well. I thought it was worthwhile just to show a few of them tonight. You might spot the odd ghostly apparition, signs of aliens passing through the village in Ray, or perhaps the odd wormhole developing somewhere in the county. But it's also worthwhile keeping a lookout for some scary looking sheep. So for those of a nervous disposition, you might want to look away now. I'll tell you, it's not that scary, so you'll be okay. It actually turned out that the sheep were quite friendly, but I think taken a bit aback by some photographers with their head torches shining their direction. Hence the reason for the reflections from their eyes, because we were shining head torches that way. But this was a fab photograph taken by Stuart Watt. He got his timing right. Unfortunately, my photograph didn't turn out because in my rush I forgot to take the lens cap off. So I got a nice black image of the inside of the lens cap. But there you go. Timing is everything. Okay, so I thought before moving on to what you can see in the night sky, I would have a quick quiz of showing you some night sky scenes from across the north of Scotland. Most are in Caithness, a few are in Sutherland. And what I'm going to do is I'm going to spend 5-10 seconds on each one, explaining what you can see while you try and figure out where the photos were taken. This may help you to identify some nice viewing points for yourselves. It's a little bit of fun. There's no prize in it, but see how many you can manage to recognise. For those of you that are tuning in from further afield than Caithness, that have never been here, just sit back and enjoy the view, and maybe it'll help encourage you to pay a visit sometime in the future. So this one here shows the Milky Way arching across the sky. Astrophotographer here taking some photographs of the aurora, and you can see the zodiacal light, the ghostly light passing up from the horizon. And for those of you that haven't recognised what it is, it's the lighthouse on Strathy Point in Sutherland. Absolutely fabulous dark location. Not too far away from there is this location here, and it's a moonlit beach. Fantastic walking along the beach in moonlight on a nice evening, especially if the aurora's out and you can enjoy the view of it in the stars. So this is Strathy Beach. Here's one a bit closer to home for me. This is a stunning display of the aurora in full moonlight. So normally the aurora is outshone by the moon. This particular display was incredible. For about 20 minutes, it was dancing across the horizon. And for those that haven't spotted the bright lights of Scrabster here on the left, yes, this is Thurso Bay, taken from Thurso Beach. A couple of photographs here showing star trails effects. Of course, we're on the Earth rotating, and as it does so, the stars move in the sky. And if you take a sequence of photographs, you can join them together afterwards to form these nice star trail type images. And on the left, you have one where the star trails form a background for Thurso Castle. And on the right, we have a popular photo spot during the daytime, which is Westerdale Waterfall, Westerdale Mill. Here, we've got the moonlight just rising, and you can spot Orion, the constellation Orion in the sky there, and it's lighting up the dam at Loch Moor. Here we've got Noctilucent and Clouds, stunning display in the middle of the night. It's not often that I can go stargazing or sky watching in the middle of the night without the need for a jacket, but in the summertime you can get away with that in Caithness as long as you time it so the midges don't get to you. So there's Noctilucent Clouds at Loch Calder. On the left, And we've got the Milky Way reaching from the horizon upwards. We've got the Summer Triangle here, 3 bright stars, Deneb, Vega and Altair. And this is above the Caithness Astronomy Group normal event location, which is Castle Hill Heritage Centre. And on the right-hand side, star trails over the log cabin in the middle of Dunnet Forest. Lighthouse here on the most northerly point in the British mainland. So this is Dunnet Head, and this was taken midnight at the beginning of June. Here we've got moonlight shining on a castle on the east coast of Caithness, and you can see a comparison photograph on the right, and it shows the view about 80 minutes beforehand, before the moon had risen. So you can see the big change in ambient light levels that moonlight causes. And finally, to finish, I'm sure everybody recognises the location that this Star Trails image was taken, which is the grey cairns of Campstor. So just to finish off, I'm assuming, seeing as I've not had anybody frantically waving at me, that the night sky is still cloudy outside. So rather than talk you through the live views that we're getting, I'll just finish with a little overview of what you can see in the night sky at this time of year, shortly after darkness falls. So if you look to the south, you will be able to see lots of bright stars at this time of year. But how do you know what you're looking at, which constellations, which stars are visible in the sky? Well, there's lots of things out there that can help you with that. And those are things like books, guidebooks, star charts, and all of these in paper format. But probably the more popular thing now is the digital format, and you can get star charts online. There is planetarium software you can use, and I would recommend Stellarium is a good one for beginners. But I suspect a lot of people will like the convenience of the apps that you can get for your mobile phone or tablet. And the advantage of these is that you will be able to hold them up in the direction you're looking, and it will tell you what's visible in the sky in that direction. The one thing you probably want to do to try and avoid your dark adapted eyes when you're out stargazing is to use a red light torch if possible. And if you don't have a red light torch, then save up the red cellophane from your strawberry creams, from Rose's chocolates or similar. I believe there are other chocolates available, so I'm not just advertising the Rose's, but red cellophane you can put over the end of your torch, and that will give you a red light that doesn't affect your eyesight so much if you're looking at star charts or guidebooks in the darkness. So after many years of stargazing, when I go out at night, what I find is I look up at the sky and I see old friends. So it's I'm a bit reluctant to compare it to this at the moment, but it's a bit like going out and meeting up with your friends in the pub, or maybe outside stargazing. You can go there and you see who's there, and you know a bit about them already because you've learned about them for many years. And I have the same situation with stars, in that I can look at the night sky and see things like in the bottom left here, you have the brightest star in the sky, which is Sirius. You have the constellation Orion here, and I'm now seeing in the side, I have Neil waving frantically at me. So I'm going to pause for a second and bring Neil in to give us an update on what the clouds are doing. Neil, you're currently muted if you're trying to speak.
Yeah, we can see a little bit of the sky, Gordon. What I'll do is I'll share my screen and let you have a look and see what you think.
Okay, I'll stop sharing when you
Okay,
go.
doing that now.
Okay.
There's an awful lot of cloud there, but we're starting to see stars showing through.
Yep. You're going to have to give me a hint as to what direction you're pointing.
Straight up the way, Gordon.
Okay. I'm struggling to see enough stars to actually
make a pattern,
identify.
yeah. Of course, it was slightly better maybe 2-3 minutes ago. It's not good enough, really, is it?
No. Thanks for your efforts, Neil. I'm really impressed that you managed to find a clear gap in the clouds above tonight.
I'll just try and get rid of this now.
When I looked outside earlier, I thought the chances of seeing one star were near impossible. Unfortunately, I don't think we're seeing enough in the way of stars there that I can talk around it for the benefit of people. So I'm going to go back to the presentation. I've just got a couple of slides and then we'll be ready to finish off. I notice I'm overrunning by a few minutes, but just bear with me. So you can see here we've got the brightest star in the sky, and the bottom, Sirius. We have the constellation Orion here. We've got the two stars of Gemini, the twins, Castor and Pollux. And because I've learned a bit over the years, I know that actually Castor is 6 stars, not just one. So it's very unusual, and that there are so many stars in a complex gravitational dance there. I know that this orangey star here is Betelgeuse, and it's a red supergiant that sometime soon will go supernova. When it does, it will probably be visible in the daytime sky. Now, when I say sometime soon, that's on stellar life cycle scales. So that's sometime in the next million years. So please don't hold your breath while you're waiting for that to happen. And you'll also notice as you look at the bright stars there, they're different colours. And the orangey red ones are much cooler than the sort of bluish white ones that you can see. And just because the brighter stars are brighter doesn't necessarily mean that they're genuinely brighter. They may just be closer, and that's the case with the star Sirius. It's a relatively close star, and that's why it appears very bright in our sky. So this part of the sky, as you look up, the bright stars actually form a couple of geometric shapes. And what you have, it can form a hexagon. So you can see the hexagon shape there from those bright stars. Or for my benefit, as my name starts with G, I quite like the big G is the other way it can be described as, which takes into account the star Betelgeuse in the centre. The 3 stars on Orion's belt are particularly good for navigating and finding other stars. So if you follow these 3 stars downwards, that will lead you to the bright star Sirius, the brightest star in the night sky. Going upwards, it takes you to the bright orangey red star of Aldebaran, which is actually the eye of the bull in the constellation of Taurus. And if you continue on past that, you'll see a faint cluster of small stars, which many of you may have heard of, the Seven Sisters or the Pleiades. And if you have binoculars, I would encourage you to have a look at them through binoculars. And if you have relatively young eyes, see how many stars you can actually see. When I was younger, I could see about 10 stars. Now my aging eyesight is not so good, it's generally about 6 or 7. So that could be a good family competition if you go out and have a look and see how many stars are visible. If we have a look at this image here, it's actually showing the Great Bear and the Little Bear. So the Great Bear you can perhaps see shaped here. Here's its head, that triangular bit. Its body is there. Its front legs there, rear legs there, tail here. And its main part of its body and its tail is actually a group of 7 stars, better known to us as the Plough or the Big Dipper. And these 2 stars here point up towards a star that's really useful for us, and it's the North Pole star, or Polaris. And the reason it's useful is it is always in a northerly direction. So if you have a clear sky at night, you will be able to tell which direction is north by finding the Plough and then using the 2 pointers, Merak and Dubhe, to point towards the pole star. So just to see whether you can pick it out yourself here, are you managing to spot the Plough sitting above the ruined building there? So you can see the 7 stars of the Plough, and then use these 2 in the end to point upwards to the pole star, just like that. Now, at this time of year, in the spring, the Plough is actually overhead. I was trying to see whether I could see that on Neil's live feed, and I suspect some of the stars we could see probably were the Plough, but not being able to see all 7, it was difficult to tell. So I'm just going to quickly finish with the part to show you what you can see or photograph with a bit more sophisticated equipment. So here we've got a photograph of Orion just with a standard digital SLR and wide angle lens. If you zoom in a bit and use a star tracking mount to take a long exposure, this fuzzy part down here can be seen in a lot more detail. And what you're seeing here is the Orion Nebula, which is a star-forming region below the 3 stars in the belt of Orion. So to the naked eye, that looks like the fuzzy patch that makes up Orion's sword. And if you take a telescope, just a small one, and point it at the Orion Nebula, all of a sudden you get so much more detail of the bright stars and dust and gas cloud that forms the nebula itself. There are a lot of people out there that won't have that sort of sophisticated equipment or camera equipment. So what I thought I would give is an idea of what you can do with modern smartphones. And here's a photograph of the aurora I took with my smartphone. Not top of the range, it's not going to break the bank. It's kind of mid-range Google Pixel phone, knocked to loose and clouds taken with it. And here you've got Orion photographed with a smartphone. And all of these were handheld. So nothing sophisticated other than you had to download an app that would allow you to get a exposure of 1 to 2 seconds in length. I think a lot of the standard apps tend not to allow you to do that. And one that everybody can definitely do is photograph the moon with a smartphone. Caithness Astronomy Group quite often have events where you can come along, put your camera phone up against the eyepiece of the telescope and get fantastic detailed images of the moon itself. Can be a little bit tricky to align the camera phone to the eyepiece, but when you do, it works very well. So anybody that has binoculars, a small telescope or a bird spotting scope, I would encourage you to give that a try. And those with a digital SLR and a long zoom lens, you'll be able to get Jupiter, that bright blob there, and 4 of the moons of Jupiter. And if your zoom lens is big enough, you might even get Saturn and its rings. Now, when you look at this image, you can perhaps see why Galileo, with his low magnification telescope 400 years ago, when he looked at the planet Saturn for the first time, he thought the planet had ears. So he didn't realize it was rings at the time. It just looked like it had things sticking out the side, like a pair of ears. But all of that without a telescope. So I'm just going to finish now with a quote that I think is quite appropriate. I really like it. So it's a quote from Robert Browning: "Night conceals the world, and obviously darkness after the sun drops will do that. But if the skies are clear of cloud, it certainly reveals the universe." So I think that's an appropriate time for any questions. And I'm not sure how many have come in, but I'm hoping that the team behind the scenes have been busy on Google sorting out the answer for me. So I'll just, do you want me to stop sharing now, Nicola, or will I leave it here at the moment, just in case there's any questions that I need to show another slide? Yeah, that's fine. Okay. How are we doing questions wise?
So, very well. You've had 14 questions, and John and I have batted some of the way and left the most interesting and difficult questions for you. So here you go. Anne McElvey has asked, where on the Bortle scale is the surrounding area of Thurso?
Thurso itself is round about Bortle 4, which is not too bad for stargazing. I mean, I do a lot of stargazing just from my back garden, purely from a convenience point of view. And of course, over the past year, there wasn't an awful lot of choice anyway. That travelling further afield was not really the right thing to do. So stargazing from the places like Thurso and Wick, you're probably falling in sort of Bortle 4 kind of territory, unless you're in the centre where there's a lot of streetlights. So in the places where you've got lots of houses with surrounding gardens, it's probably reasonably good. If you go out, you don't have to go very far to get to Bortle 2 sort of territory. Lochmore is easily Bortle 2 level, and if you go out to Forcenard in Sutherland, you're probably straying into close to Bortle 1 sort of range. So now that I've answered the question, I've realised we've both been using a technical term here that maybe a lot of people don't understand what the Bortle scale is. The Bortle scale is a bit like the Beaufort scale for wind. So the Beaufort scale for wind gives you degrees of how windy the conditions are. So 1 is there's next to no wind at all, 10 is hurricane. The Bortle scale gives you degrees, instead of wind, it gives you degrees of darkness and clarity of sky. So Bortle 1, you won't be surprised to hear, is the really good, and Bortle 10 is probably standing underneath some floodlights in the middle of London or something like that. So you can do a lot of good stargazing from Bortle 5 down to Bortle 1. The fact that there's remote parts, albeit, of Scotland where it's Bortle 1, I think is testimony to how good the sky is for stargazing here. The really best kind of dark skies are probably on a desert island somewhere in the Pacific, which is definitely Bortle 1 sort of territory. But like I said, far reaches of Sutherland, you're probably talking borderline between Bortle 2 and Bortle 1 sort of range. So that was quite a long answer. Hopefully that provides the information that was required.
So hopefully Anne will message us saying it's okay. Otherwise, there'll be a follow-up question, I'm sure. Just before I ask the next questions, and they're coming in fast and furious, could I ask Sky and Kira Alino, you have your hands raised. If you have a question, could we ask you to put it through the Q&A first? And if we can't answer it directly, then we'll direct it to Gordon. So the next question for Gordon is a question you answered during your talk, but maybe you'd like to give it some specific addresses. How often do you think we get the aurora in Thursday? And that's from Tracy Wright.
It depends. One of the things I didn't explain is that the aurora, well, I did explain that the aurora is tied into what the sun's doing. The problem is the sun goes through a cycle of activity. So there are periods where the sun is not as active as other times. The main periodicity of the cycle is roughly every 11 years. So you'll have a peak in solar activity followed by another peak roughly 11 years later. And it's during the peaks of activity that you will see the aurora most frequently. And it is quite a marked change for how often you'll see it from the north of Scotland. If you're in the Arctic Circle, you'll see the aurora lots of times, if the weather allows, because you're far enough north. For slightly further south than we get in the north of Scotland, it is going to be far less frequent during the solar minima, which we're just coming out of at the moment, compared to the solar maxima. So in the periods and years where there's solar maximum activity, I would expect to see the aurora at least 30 times in a year, 30 separate nights. Now, when you take into account that I can't see the aurora when it's cloudy, I won't be able to see the aurora generally if it appears after midnight, because I'm off to bed so I can get up for work in the morning. That rules out quite a lot of nights in the year. And during mid-May through to mid-August, it's not dark enough to generally see the aurora. That means that 30 nights over the remaining months is quite a high frequency and a reasonable chance of seeing it from the north of Scotland. However, at solar minimum, which we're round about at the moment, we've just passed it, it's far less frequent than that. And I'm reasonably happy to see the aurora a couple of times a month over the winter months. So it's probably an increase fourfold during maxima compared to solar minima. So I don't know if that covers it. Some of those times you may have to go somewhere a little bit darker than Thurso to see it. The photograph that you can see just now is from my back garden, taken at midnight on Hogmanay a few years ago, where myself and the rest of the family took in the bells, watching
Gordon, you're on speed round now.
Sorry, say that again.
You're on speed round now. You have 4.5 minutes for 13 questions. So Nicola is giving me a good. Okay, I have the boss in command. So, Anne has said thank you very much. Their answer is full. So you're on a kind of quick fire round now. Okay, ready?
Okay.
So Bettina Bally has said, talk, many thanks. Any idea of an Android app for doing sequence or stacking of photos, particularly for star trails?
Sorry, can you say the first part again?
Any Android or any app for, or I suppose for computers, we'll expand it slightly, for sequencing photos for star trails. I know you have one that you use.
Yes, there is 2 bits of free software that are available for PCs. Unfortunately, I don't have an Apple, so I can't recommend anything for it. But one of them is, if you type in Star Trails, it's free software produced by a person in Germany. The other one is Star Stacks, which is StarStacks. STAX, and they're both very straightforward to use, do a fantastic job, and I use them. Okay, next.
Super. Next question is Michael Spurs. What kit are we using for doing our live sky surveys? So I know we just recently got a nice grant from the wind farm. Maybe you'd like to say about that.
Yeah. What Neil was using tonight was a ZWO camera, 2 megapixel, and it was able to fit a fisheye lens on the end of it. If you want the technical model, it's a 290 MC. So that's in relation to the sensor, and the C stands for color. So hopefully that answers your question. We do intend to buy shortly, because we've acquired funding, a more sophisticated camera for deep sky views as well. Okay, next.
So next one is the fabulous Aurora, and you showed some cracking pictures from the smartphones, but Alison P has asked, when I spot northern lights, I never have my camera, just a mobile phone. If you get any particular settings or an app you can recommend, I'm adding Alison, to suggest to use, because the pictures aren't always as fantastic as you would like.
Yes, at the moment.
So any app or any settings for the smartphone?
Yeah, at the moment, the app I'm using is a beta version, so I'm not sure if it's still available or not. There doesn't seem to be a wide selection that allow you to take the long exposures required, but what you're looking for is an app that will allow you to take something like a 2-second exposure with an ISO setting round about 6400 or thereabouts. And unfortunately, most basic camera phone apps don't allow you to do that. So I'm afraid you're going to have a search for it, because the one I've got was a beta, and I don't think it's available at the moment, because they're looking to formally release it. Okay.
So next one I got is from Johnny Balky. Fantastic talk, thanks so much. Looking at the picture of the Milky Way, is there a difference between what you see when looking in towards the middle of the Milky Way or looking out towards the arm of our galaxy? And do these happen at particular times of the year?
Yes, there's a massive difference. Looking towards the central bulge of the Milky Way, it's much, much brighter and bigger. Unfortunately, from the north of Scotland, we cannot see the central bulge. Part of the central bulge peaks above the southern horizon, but only just. If you go to the southern hemisphere, Australia, South Africa, South America, the main the central part of the Milky Way is high above the horizon from there, and it is blatantly obvious to the naked eye. It really does stand out. It makes it much easier to photograph as well. Unfortunately, I have never been that far south, so I don't have any photos to show of it, but all of the photos of the Milky Way I've shown tonight are of the less dense, the less bright parts that you can see, which are looking along the spiral arms rather than towards the center. Okay.
So I can see it's 20:27 and 8, 9, 10 seconds, and Nicola will is in firm control of me. I think a recurring theme of a question is maybe you could get, I'm going to paraphrase it. For beginners, apart from going to the BBC Sky at Night telescope magazine, what kit can you recommend beginners to start out?
That's a question that I would struggle to answer in 20 minutes. 20 minutes wouldn't do that one justice. So it depends on what you're going to use the telescope for. And most beginners, unfortunately, don't know at this stage. I think maybe the best thing is, obviously following on from this, what we can do is take a note of the questions, and I'm quite happy to have a look at them and provide some suitable answers or web links that will give guidance, such as the question there, which is not an easy one to answer, and certainly not in a few minutes. So we can perhaps do that and make that available via either the Caithness Astronomy Group website, Facebook page, or via the Science Festival in some way. So if we can make sure that we keep a record of the questions, I'm quite happy to go through them and provide some answers for people to look at afterwards. That may be the simplest solution.
Yeah, so I at the danger again saying, Gordon, there's most people want to see pretty pictures. There are different telescopes that are good for doing the with basic cameras, yeah. And there are different telescopes for more sophisticated equipment, which is why Gordon is. I'm speaking for him. Slightly reluctant to tell you to go and spend large amounts of money. So the problem is that always with astronomy is that everyone wants to see Hubble Space Telescope pictures, and we can't do that from the ground. So no. there are many things that we can do, and it's really a super hobby. But depending on what people's aspirations are, there are different bits of kit that are optimized for the things that you want to see. Is that an interjection, Gordon?
I think that's a perfect answer. The one thing I would add to it is, if you get in contact with your local astronomy club, and if that's Caithness, then we'll be happy to provide more detailed advice. But it's not something we can answer simply. The one thing that your local club will do is probably to encourage you to go along to the next time they have an observing session, when they have equipment out in use, and you can see for yourself what the equipment's like and what it's like to use it, because there are so many different considerations. It's not something you can give an easy answer for, especially when some of the equipment can be quite expensive. So it's not something you're going to do without proper consideration beforehand. Okay.
So I'm sorry that we can't get through all questions. We do have a record of it, and through Science 03 and Caithness International Science Festival, we'll get back to you all. Maybe if Nicola will permit me to add one thing, for those of you that are in the catchment area, if you like, at Caithness Astronomy, we do have a website, Spanglefish. I believe it's online. We also have a Facebook page. We have a reasonable amount of equipment, and we are, COVID-19 notwithstanding, we are an active group that is happy to have new members and lots of people who are interested in joining us for observing sessions. So unless our chairman has anything further to add, it's probably time to hand back to Nicola and to Ian.
No, I think that's perfect. So back to Nicola and Ian.
Hello, I think, am I up now, Nicola? Yeah, thanks. Thanks everyone for attending this first event this evening, and for all your questions. I counted 40 or 50, so that was really good. It's hard to get through them all. We'll dwell on the questions and how best to answer any that weren't answered in the live session. I'd like to offer a huge thanks to Gordon and Caithness Astronomy Group for joining this evening, and for all the hard work that went into delivering the presentation. It was a fantastic start to this year's live events and a great introduction to us all. We were delighted by the turnout. When we started, there was over 170 people, so that's excellent, really good. The The Caithness Astronomy Group will be joining us later this month to deliver a guided tour of the moon over 3 consecutive nights, the 19th, 20th and the 21st of March, all starting at 7 o'clock, weather permitting. Since we got the news of the Mars rover Perseverance landing, maybe for our next festival, Gordon will be giving us a guided tour of Mars as well. Who knows? There's still time to book tickets for events taking place over the next few days, including Cracking Cryptography, which is tomorrow at 11 a.m. And you can try your hand at writing and decoding encrypted messages. I'm sure you're aware that there's been a hack, a Microsoft hack, infecting 3,000 businesses in America, and they're putting it down to a Chinese cyber espionage unit. So maybe they attended the lecture as well. Dr. Mike Sims will join us on Tuesday, the 9th March to talk about meteorites and how they help us discover just how amazing our solar system is. On Wednesday, 10th of March, former astronaut Dwayne Carey, Digger, as we know him in Caithness, will join us all the way from Colorado Springs to tell us about the latest plans for us and to visit and eventually live on the moon, which sounds very exciting. All details are available on Science 03. It's called Science 03 because we started in 2003, so science03.org, and let anybody know what we're doing so we can broadcast what we're doing. Thanks again for joining us tonight. We hope you enjoyed it and you'll enjoy the rest of the 2021 Caithness International Science Festival. Thank you very much. Thank you. Bye-bye. Bye-bye, everyone.